Okay, here's warm-up number 7.1. I'm going to factor this trinomial. So I'm always looking for a common factor, especially when I've got a coefficient in front of the x squared. I can't factor out 3, though, or anything else as a common factor. So what I'm going to do is a modified diamond problem. I'm going to pull the 3 and multiply it by the -8 to change this trinomial. So the 3 just kind of disappears from the front. 3 times -8 is -24. Now I'm going to factor this with the diamond problem. So I'll put the 10 up there, -24 there. I'm looking for now for two numbers that add to 10. Same two numbers multiply to -24. It's tempting to use a 4 and a 6 because they add to 10 and multiply to 24. But remember, one of them would have to be negative. So that doesn't add to 10. This doesn't add to 10 either. So that's not my winning combo. Let's try a 12 and a 2. I can do something with a 12 and a 2 if the 2 is negative and the 12 is positive. That is my only winning combination there. So this factors into x plus 12 times x minus 2. This is not my final answer, though, because I changed the problem. So now I got to change this answer back. So what I'm going to do in the beginning, I multiplied by 3. So now I'm going to do the opposite. I'm going to divide the number parts by 3. Okay, like so. And I'll reduce as much as I can. 12 divided by 3 is 4. I can't reduce 2/3, so if you have a fraction that's completely reduced, take the denominator and pull it out in front of the x, and then the 2 falls to the ground, and there is my solution. And many other ways to factor as well, so this isn't the only way. You could always test it out, FOIL it back together, and you should end up with 3x squared plus 10x minus 8. Okay. Speaking of foiling, I've got two binomials here, so I'm going to FOIL them. So first, 3 times 2 is 6. Outer would be -9i. Inner is going to be 8i. And then last would be -12i squared. Okay, I'm going to start cleaning this up a little bit. Got those like terms in the middle. Okay, now you got to know a little something about this I with the like that with the little tail. So that means the square root of -1. I hope you know if you're watching this. And then if I take this equation and square both sides of it, I squared then is going to equal -1. So I've got a hidden -1 here. I can this is going to simplify to -1. So this term here is really -12 times -1. So -12 times -1 would be positive 12. Okay, and now, hey, I've got more like terms that I can combine. I can combine those into 18. And then you always want to write the real part first, then the imaginary part. Okay. All right, next up. We've got an inequality here, a quadratic inequality with one variable. So there are a whole lot of different things I can plug in for x. I could start listing them. Like 100 would work, or 200 would work. There's a lot of them. I don't want to list them. So what I'm going to do is I'm going to graph them on a number line. Or you can write an inequality to express all the x values. That'll work because it's an infinitely long list. So what I want to do is to divide the world into x values that are a solution and x values that are not a solution. So since I've got a quadratic trinomial over here, I'm going to factor it. I'm just going to treat this like an equation for a minute. So I'm going to factor this, and you could factor this one straight up with a diamond problem. So, you know, do this, right? And I'm looking for two numbers that add to 2, multiply to -15. So how about -3 and +5? So then I got -3, +5, and I'm going to solve this. So if x minus 3 equals 0, then x equals 3. If x plus 5 equals 0, then x equals -5. Okay, these are not my final solutions. This would be if I had an equation, but with an inequality, it's not my final solution. But those are dividing points. So now if I graph I like to just put these on a number line. I'm going to put those 2 points on my number line. Make sure -5's to the left, okay? And since I've got, this is not underlined, so my solutions then, my dividing points are not going to be included. So that means I've got open dots. If this was underlined, I'd have closed dots, okay? And now I got to figure out, am I going to get arrows going? Usually you'll have alternating parts that are solutions and not solutions. So usually it'll be either arrows going outwards or they'll be connected in the middle. And what I'm going to do is do some test points. So I'm going to test out some different values, like I'll test -6 in the original inequality and see if it comes out true or false. So here, I'll do that up here. -6 squared plus 2 times -6 minus 15 is greater than 0. So let's see, 36 minus 12 minus 15. And I've got, what is that, 36 minus 27 then. And that's going to be 9. So 9 is greater than 0. That's true, right? So when I plugged in the -6, that was true. So this is going to be a true region. So I'm going to have this happening. And any test point to the left of that -5, you should get an inequality that works, okay, a true inequality. So I'm guessing this is going to be false in the middle. My favorite number to use is a 0. That's just the easiest. So I'll try that out here. I'll do that over here maybe. So going back again to the original inequality, and then -15 is greater than 0. No, it's not. -15 is less than 0, so this is a false region, so I'm not going to have any solutions there. And I'm guessing this last one's going to come out true, but just to make sure, let's try +4. I'll work up here. Okay, let's see, 16 plus 8 minus 15. So that's going to be 9 again. 9 is greater than 0. That's true. So this is my solution. You could write this in as an inequality if you wanted, but I like to just do the number line graph to show the solutions. Anything less than -5 or more than +3. Okay, last problem. We're going to look at the end behavior of this. You could graph this, but it'd be a huge pain because I've got some large exponents here and some large coefficients. I'm not going to graph this. I'm going to what I'm going to do is I'm going to think of I'm going to look at the leading term first off. I'm going to look at the leading coefficient here. My leading coefficient, I'm just going to write LC for that, is negative. Okay? And then the degree of the whole equation is going to be even because it's 44th degree. It's the same as the degree of the leading term. So I've got an even degree with a negative leading coefficient. Now what I'm going to do is write another equation that I can with these two same characteristics, but I'll make the simplest one possible. Okay? So how about, I need an even degree, got a negative leading coefficient there, y equals -x squared. That's my simplest possible equation that is negative leading coefficient and even degree. And these two equations are going to have the same end behavior. So if I know the end behavior here, which I do, this is a parabola that opens downwards, so it's going to have that end behavior. I don't know what's happening in the middle or exactly how it's going to look, but I know on either end it's going to be going down. Okay? So now I just got to write this in a mathematical way. So I'm going to say as x approaches negative infinity, that means as you're going left on the x-axis. Let's say that this is centered at 0, 0. So if I go left on the x-axis, as I go left to the far left, I'm going to go down on the y-axis. So in other words, as I go left, I go down. So as x approaches negative infinity, y approaches negative infinity. Okay? And then as I go right on the x-axis, I'm going to go down on the y-axis. So as I go right, I go down. Oops. As x approaches positive infinity, then y is going to also approach negative infinity. So as I go left, I go down. As I go right, I go down. That's another way of saying that. Okay? And that's it for this warm-up, and I'll see you next time.